Hello again. In this session, we're going to explore three core ideas used constantly in data analysis and research: hypothesis testing, statistical significance, and regression. These concepts help us move from guessing based on intuition to making decisions supported by data. By the end of this lesson, you should understand not only the definitions, but also how and why these tools are used in real-world analysis. Why statistics matter in decision-making. Organizations collect data to reduce uncertainty, but raw numbers alone don't tell us what to believe or what action to take. Statistics gives us a structured way to test assumptions, evaluate evidence, and determine whether observed patterns are meaningful or just random noise. What is a hypothesis? A hypothesis is a testable statement about a population or process. It represents a claim we want to evaluate using data. For example, we might hypothesize that a new training program improves intern performance, or that increased study time leads to higher exam scores. Null and alternative hypotheses. In hypothesis testing, we always define two competing statements. The null hypothesis assumes no effect or no difference. The alternative hypothesis represents the effect or difference we are investigating. We don't try to prove the null hypothesis. Instead, we test whether there is enough evidence to reject it. Thinking in terms of evidence. Hypothesis testing is not about certainty. It's about weighing evidence. We ask, based on the data we collected, is the observed outcome likely to have occurred by chance, or does it suggest a real effect? Introduction to statistical significance. Statistical significance helps us answer that question. It tells us whether the results we observe are unlikely under the assumption that the null hypothesis is true. If they are unlikely enough, we consider the result statistically significant. Understanding the p-value. The p-value is a probability that measures how extreme our observed data would be if the null hypothesis were true. A smaller p-value indicates stronger evidence against the null hypothesis. It does not measure how important or how large an effect is, only how unlikely the data is under the null assumption. Common misinterpretations of p-values. A p-value is often misunderstood. It does not tell us the probability that the hypothesis is true or false. It also does not guarantee practical importance. Statistical significance simply indicates evidence, not certainty or impact. Significance levels and thresholds. Before running a test, we choose a significance level, commonly 0.05. This threshold defines how much risk we are willing to accept of rejecting a true null hypothesis. If the p-value is below this threshold, we reject the null hypothesis. Errors in hypothesis testing. There are two types of errors we can make. A type I error occurs when we reject a true null hypothesis. A type II error occurs when we fail to reject a false null hypothesis. Understanding these errors helps us interpret results cautiously. Moving beyond testing. Why regression matters. While hypothesis testing focuses on comparing groups or outcomes, regression helps us understand relationships between variables. It allows us to model how changes in one variable are associated with changes in another. What is regression? Regression is a statistical method used to describe and quantify relationships between variables. It helps us predict an outcome based on one or more predictors and understand the direction and strength of those relationships. Simple linear regression explained. In simple linear regression, we analyze the relationship between one independent variable and one dependent variable. The model fits a line that best represents the data, showing how the outcome changes as the predictor increases or decreases. Interpreting the regression line. The slope of the regression line tells us how much the dependent variable changes for each unit increase in the independent variable. The intercept represents the expected value of the outcome when the predictor equals 0. Statistical significance in regression. Regression coefficients are often tested for statistical significance. This helps us determine whether the observed relationship is likely real or could have occurred by chance. A significant coefficient suggests the predictor contributes meaningful information to the model. Correlation versus causation. Regression can reveal associations, but it does not automatically imply causation. Just because two variables move together does not mean one causes the other. Careful study design and domain knowledge are essential. Model fit and explanation. Regression models also tell us how well they explain the data. Measures like R-squared indicate the proportion of variation in the outcome explained by the predictors. Higher values suggest better explanatory power, but context always matters. Practical applications. Hypothesis testing and regression are used across many fields, from healthcare and education to economics and technology. Interns might use these tools to evaluate interventions, analyze survey data, or support evidence-based recommendations. Common pitfalls to avoid. Always question assumptions, check data quality, and avoid over-interpreting results. Statistical tools support decision-making, but they do not replace critical thinking or subject matter expertise. Key takeaways. Hypothesis testing helps us evaluate claims using evidence. Statistical significance tells us whether results are likely due to chance. Regression helps us understand and model relationships between variables. Together, these tools form the foundation of analytical reasoning in data-driven work.